Good evening, everyone. My name is Sam Nasser, and this is the Azure Cleveland User Group. A little bit about the group. We meet typically every month on the second week of the month. However, this is a slight difference due to scheduling changes. The meetings are free of charge and open to the public, and we cover a variety of topics related to Azure, whether it's infrastructure as a service, platform as a service, or software as a service. You can find all the meeting information posted at the link listed at the bottom of the slide on meetup.com. We'd like to give a big thank you to our sponsors, the .NET Foundations for sponsoring the Meetup website, and NIS Technologies for sponsoring the virtual meeting space. If you're new to the user group or attending or if you haven't attended in a while, some general information, please keep in mind that participation is encouraged, and the only stupid question is the one not being asked. This serves as a live forum if you're joining us live, either on YouTube or through GoToMeeting. And so that it involves a lot of give and take, meaning if you have any questions, feel free to enter them into chat. If you're watching this on YouTube, I encourage you to enter in a comment. Those are monitored on a regular basis, and we'll get back to you shortly. And if you're joining us live, ask you to please mute your microphones just to avoid any background noise. And we want to keep it casual but organized, meaning jump in with a question or a comment. However, we want to make sure that our speaker has enough time to go through the slides and the demos. And as I mentioned, the presentation is being recorded and will be posted on YouTube shortly after the editing process. So for tonight's feature presentation, it is Implementing Lakehouse Using Databricks and Delta Lake by Mehul Bhuva. Mehul joins us from West Des Moines, Iowa. He has over 20 years of software development experience, specifically in the AI and the data platform. He has experience in the Azure Data Factory, Azure Databricks, and AI Foundry, just to name a few. In addition, he is a Microsoft Azure Data Engineer Associate, and you can find a lot of his postings posted at sharepointfix.com. And so with that, Mehul, welcome to the Azure Cleveland User Group. Glad to have you.
Thank you, Sam, for the introduction. This presentation is based on my very recent paper that I published a couple of months back in one of the very popular journals, which is the Seventh Sense Research Group. The article is Implementing Enterprise-Wide Lakehouse Using Microsoft Azure Databricks and Delta Lake. I'll share the link later on. But I've created a short presentation based on the paper. And you can basically go through the paper when you get a chance, right? I'm going to cover majority of the topics that I've shared in the paper in the form of presentation slides, which are more easy to understand and digest. So let me take you through that. So again, a short introduction. My name is Mehul, and I have 20 years of software development experience. For the most part, I have been on the app side, but I've always done a lot of data engineering, data modeling in the past. Started with VBASP, mostly all Microsoft stack technologies, VBASP way back in 2004, and then eventually graduated to .NET, writing .NET apps for front end and back end both. Always been a full stack developer, not just a front end UI developer. Written a lot of APIs and worked on Azure right from the inception. And then ADF is what I got fascinated with, writing the pipelines, the data engineering pipelines, ETL pipelines, things like that. Eventually got into Databricks, which was even better kind of, technology landscape comparatively to the other things I've worked on. Very robust, very solid. And that's why I wrote the paper, so that I can share what I've learned. I worked with QCI. It's a local company. It's a consulting company in Des Moines. I've consulted Fortune 500 clients, including GM, Amgen, and a leading agri-science company. So that's a short introduction. Again, the agenda for today's presentation is going to be how the data architecture has evolved over a period of time. Difference between a data warehouse versus a data lake versus a data lakehouse. Research gaps in my paper that I was trying to address in the problem statement. Lakehouse architecture and implementation, how I went about, me and my team here went about architecting and consolidating things and talking to the business stakeholders and trying to show them the value. Because one thing is that the business and the companies are focused on the cost mostly. Whatever takes them from point A to point B the cheapest, they want to go there. But it's mostly the value that they should be looking, the long-term value of a solution or a technology. That's what we try to encourage our clients to do. Real world case study of an agriculture technology company. That's what the paper is based on. Performance, and then I compare the performance between the previous stuff that we were on and then the new technology that we were in. And then I also share some competitors to Databricks so that you get a perspective of who are the other players in the market. Challenges and lesson learned, those are important because so no product is perfect, no technology is going to solve all the problems. It's going to be a trade-off, right? When you compare technologies, some technology like Snowflake would have one specific area better than Databricks, and Databricks would be more robust in other areas. So it's not a perfect world. It's not going to be, there's no perfect solution in our industry. And then future directions for the research. So any questions so far, or we're good to go? Okay, I'll keep going. So the modern data challenge, right? So 90% of the world's data was created in the last 2 years. What does that mean? It means that there is a lot of data out there that people have started realizing that this is going to be of immense value to my company, my business, my customers, how I make decisions, how I plan for the future, right? There is 2.5 quintillion bytes of data created daily. And 80% of enterprise data is mostly unstructured. When I say unstructured, it's in form of the document somewhere, text files, videos, things like that. Blog posts, now podcast, I think these are all forms of unstructured documents or unstructured data. So the data that's collected in an organization is all mostly in silos, and one team does not know what the other team is working on. At the same time, they don't have full insights on the data, so they try to recreate each time. There have been several cases where we have seen that, hey, this data is already available with me, but I have to go from pillar to post to find it out where it is residing, and what are the connection strings, and go and take permissions, and it's a big loop. And Databricks solves a variety of these kind of problems. Tries to integrate the silos. Governance gaps, there's a lot of inconsistent security and compliance across platforms. Now there's HR data and marketing data, organizational data, right? Compliance data. There are a lot of governance issues. There's also research data, which I primarily worked on, which is very, very sensitive. And region specific data, which is very, very sensitive to certain regions. Those need to be protected. There have to be security in place, row level security, column masking, things like that. So security is a big aspect of, and data governance and security is a very big aspect of this. Performance issues. Now, there are a lot of databases so prior to this, I was working on Azure SQL database, standalone database that the company had stood as a warehouse on its own. It did not have the bells and whistles of a warehouse, but it was treating it like one. So no matter whatever optimizations you do, no matter how much indexing you do, no matter how much partitions you create, that's not going to give you the horsepower that a Lakehouse has. It is not a massive parallel processing system. It does not have the bells and whistles. The underlying format is not going to be supported, right? It's not going to be performant enough. So those are some of the issues that I dealt with when I was researching on this. Integration complexity, ELT, ETL overhead, ETL for, it's extract, transform, and load, and ELT is extract, load, and transform, right? Between analytical and operational systems. Now there is a complexity where you have to pull data from these systems and present it as a reporting database. That is an overhead for these analytical and transactional systems, right? Imagine a banking website which is generating millions of transactions a day, and if you have a query on top of that for your reporting purposes, that's not a great idea. Cost inefficiency, multiple platforms. Now we have hundreds of teams in a company, and they have hundreds of databases. Imagine each company, each group or each app owner have its own reporting database instance where they are creating backups, or creating mirroring for their database for reporting purposes, let's say once a day. But there are so many instances of those databases that they are hard to keep, hard to manage, hard to maintain from a security perspective. They get obsolete, they have to be upgraded. Uh, there are a bunch of issues. The costs keep rising all the time. That's what we had in our organization. The cost of these databases were growing exponentially. As the not just the cost, but also the manpower needed, the resources needed to manage so many databases were also growing at an enormous pace, which means more cost. If you have more people managing those databases, you have to pay those people. So it's not just the infrastructure cost, but also the cost of paying people to manage those databases. So that was compounding. Now, uh, I do show a difference between, before I start, what is a data warehouse, a typical data warehouse versus a data lake versus a data lake house, right? So a data warehouse is where you have mostly structured data, right? When I say structured data, those are your relational databases where you have a row column table structure, and you have relationships, you have entities, you have for constraints, things like that. They have ACID properties, atomicity, consistency, isolation, durability, things like that. Their schema is on right, and performance is high for BI queries because it's a standalone instance. And we had this problem in the consulting firm that I was working on, or the client I was consulting. So they had all these kinds of databases as I was talking about, and they had a good amount of BI, Power BI, ahead of it, right? So people were writing and reports on them, and querying them all the time, and it was not scaling that fast enough. For performance was pretty bad. Um, Cost, the high compute and storage cost, as I mentioned earlier, the storage and the infrastructure cost was very high, including the resource cost to manage those databases. Use cases, uh, we were using it primarily for reporting and analytics purposes. Now, coming to a data lake, now it can store all types of, so that's your data warehouse, right? Your data types can only be structured. Now, data lake is a more advanced concept where you can have all types of content, structured, semi-structured, unstructured. Schema is only on read, which means you can store information like an AWS S3 bucket or a storage or a blob container. There is no ACID transaction properties. So you can have corruption and you could have data failures and things like that. Performance is reasonably slower. It's variable. Sometimes it's fast, sometimes it's slow, but most of the times, on average, it's pretty slow compared to a data warehouse. Cost is low. Storage is always cheap, but so the cost is not a concern when it comes to a data lake. Use cases are like your machine learning data scientist, and for archival purposes, you can have a cool tire or a hot tire and things like that on the data lake. Um, Coming to data lake house, how is it different from a warehouse and a lake and a data lake? Again, it supports all types of data, structured, semi-structured, unstructured, and then you have a lot of schema reinforcement there. Schema evolution with enforcement. So as the data changes, the schema also evolves over a period of time, and the data lake house will capture all that for you. It has full ACID transaction properties similar to a data warehouse with the open source Delta Lake format, which is faster. Mostly it is Parquet files. Parquet files are columnar storage that are way easier and faster to process. Um, all the massive data lakehouse platforms support Parquet files and recommend using Parquet files. On the back end, the Delta Lake tables are all Parquet files, by the way, by default. So performance high for both BI and ML. Of course, it also adds it can integrate not just your data engineers, but you can also have your scientists, your AI engineers, your machine learning engineers, your data analyst working on the same environment or the same workspace and share the catalogs and things like that, which we will go over in a bit. Cost is medium, it's optimized compute. So your compute is a very important aspect of Databricks. People have burnt themselves by not optimizing their compute levels, and then they complain that Databricks is costly. There are different types of computes available: serverless, all-purpose job compute, and then SQL warehouse. Right. So these are three major types of computes that we have on the Databricks. For the most part, every use case is different. You would use a job cluster or job compute for your machine learning notebooks, and if you want to run long running jobs, serverless is for jobs that are quick and easy, and it can get done faster, like your DLT pipelines or workflows. And then the warehouse can be used for typically your Spark SQL queries, writing relational queries, things like that, creating materialized views. You can use SQL warehouse for those. So it is the use cases for a data lake house is it's like a unified platform for that serves each and every entity in your organization, be it your scientists, your data scientists, your data analyst who are mostly working on Power BI, and then your machine learning folks, and your business users who want dashboards and want to see their dashboards and things like that. It's also useful for IT organization or IT app oriented entities where they want to see their data and they want to collaborate with other teams and create an app which is like a mashup of all the data. So we had a need where we wanted an app that gets data from SAP, that gets data from a LIMS system, and basically mash up the data and show the value of the data to their business folks. So you can share catalogs, and you can create apps based on that too. Now, there are different kinds of apps. Databricks also has its own set of apps that you can write. The backend, you can choose your backend. It mostly is Python that we use on the Databricks side. Any questions so far? If there are questions, definitely interrupt me, raise your hands or whatever. That's totally fine. So the research gap for my paper was, again, the critical challenges in the current landscape, right? Separate data, as I mentioned earlier, separate data lakes and warehouses, people working in their own silos, very hard to get access to, you have to run from pillar to post to get access. We know that there is a data out there, but it takes a while to figure out where to go and grab the data from, and there's very less documentation. The data is not shared very easily across, when you have lakes and warehouses. Data duplication. A lot of times we have seen that the same data existed in multiple places for different needs, for different purposes. This was one of the gaps, challenges that we found. Inconsistent governance models. Some of the places we had very low security compared to the other entities who were keeping their data super secure. So there was no single governance model for this, or there's not a unified governance models for their data within the organization. High maintenance cost, as I mentioned, this is a very, very big factor. On the top level, people only the business cares about numbers. And one of the biggest drawbacks of this is if you have multiple lakes and warehouses, you have high maintenance cost. Infrastructure, there was a lot of data infrastructure issues too, like lack of ACID transactions in data lakes, no schema reinforcement leading to data swamps, poor data quality controls. And we have seen loss of data too at times where certain data was deleted and it was very difficult to recover the data, or time travel and look at schema evolution, things like that. Integration and governance, again, complex ETL. Now every system has their own ETL process, from their transactional processing or transactional processing systems to the reporting system or the analytical databases. So that means that you have so many pipelines running in the organization. They're all built differently. One is on Redshift versus one is on ADF. There's no unified strategy for even doing data engineering if you have these many silos. Delayed insights due to data movement, right? The data is moving pretty slow, as there is no unified way to move data across the environments. And sometimes you don't see the fresh data. If you're reporting, you want fresh data each time for the most cases. Unified security challenges. There was a challenge to have a unified security across the board. Compliance enforcement difficulties, right? There's difficulty, having compliance, especially for sensitive data. Industry impact, of course, particularly acute in regulated industries, financial services, healthcare, agriculture business, research-based business where your data is the key, right? If your data is leaked out, then you lose your intellectual property. Data integrity and governance are paramount. So these were some of the research gap and my problem statement. One of the questions that asked was, how can enterprise organizations implement a unified lakehouse architecture using Databricks and Delta Lake to overcome traditional limitations that I've mentioned here in the slide? while maintaining governance, performance, and cost effectiveness, right? So that was one of my primary research questions when I began this paper. Um, then we come to how we implemented the Lakehouse in at the current client that I'm working for, um, and what are the core components associated. Now we chose Databricks. We evaluated other products too, but we found the most bang for the buck with the Databricks because it was more unified, more robust, and we were able to. It was easy, of course, not very easy in terms of the learning curve because you have to write Python, and I am a C#.NET developer, so you know how that goes. But uh, it was very it was it was a no-brainer. When we looked at the other products versus Databricks, there was no comparison, and the way their future looks like, they keep buying more and more companies. They recently bought NeonDB for a $1 billion transaction, so they keep acquiring, and every single day I'm seeing new features rolled in every single day. Um, so based on those things plus cost versus value comparison, yes, it is costly. It's going to cost you dollars, but the value of this is immense. It's not cheap by any which ways, but the value it brings to the table is amazing. And so essentially, yeah, that's why we chose Databricks over the other competitors like Snowflake and Amazon, AWS, Redshift, and there's a slide out there for competitors. There's also Google BigQuery. So the best part about this was, let's say if my organization, one of the biggest drivers of this was the value, and then the second one was because it's cloud agnostic, which means that you can deploy, it's compatible with AWS, Databricks, and Google Cloud, which means that in the future, if the company decides to switch its cloud provider from Azure to AWS, let's say, it will be compatible. We don't have to change anything on our side except for those connectors. Easier said than done, but that was the value proposition, right? That if you move across the clouds, we can basically make you up and running in no time. So that was one of the other very important factors in choosing Databricks, that it's cloud compatible, or cloud agnostic. So the Azure Data Lake Storage Gen 2, that's the Delta Lake format, the open source Delta Lake format that we have been using under the hood. So all the tables that we create, all the Delta tables, Delta Live tables that we create are stored as ADLS Gen 2 storage under the hood. So that's that. Then we have a concept of Delta Lake tables or Delta Live tables. They have all these properties that I spoke about earlier: asset transactions, schema reinforcement, time travel, things like that. And Unity Catalog is their common centralized governance and data discovery and access control model. This is the beauty of the Databricks product, that earlier they were in the Hive meta store, which was not very good in terms of governance. So they moved to Unity Catalog, and there are a bunch of projects out there who are upgrading from Hive to Unity Catalog in our company too. So it's not a very painful process, but it can take some time to upgrade. So Unity Catalog is way better from a government's perspective. Now, with my experience, right, it's been very easy to assign permissions to a specific group of people, or revoke permissions, or have granular level security to your catalog schema and table level, and even row level and column level security using the governance model here, and the security model. Consumption layer, I mean, you can have Power BI connected. There is a way to connect, to basically go and publish. And I was just documenting this today for a business user. How do I, if I have access to a presentation layer, let's say, how do I hook it up to my Power BI desktop or Power BI works? How do I publish that whole uh, catalog and schema to Power BI as a Power BI semantic model or as a Power BI data flow? That is a one click on the user interface. Now the downside to that is that you need a premium workspace to be able to publish from Databricks to Power BI directly. But there's an alternative, that if you want to publish from Databricks to Power BI, you can create a pbits file, which is a Power BI data set file, and that will help you. And then when you open that file, it will basically ask you to select your tables, your Delta tables that you want to connect to. So that is a workaround that we are using for non-premium workspaces. We cannot, unfortunately, go and publish it because premium licenses are expensive and we don't want to upgrade all our workspaces to premium workspaces. So it's like a $5,000 per month or something. I hope that that feature, they change that in the future. Synapse, again, it's another analytical platform that you can use to connect to a Databricks instance. And then, of course, you can write your machine learning notebooks, right? There is ML flow there on the Databricks. There's also Databricks apps now, which can be used. So we were working on a RAG-based chatbot using a Databricks app that uses LLM models and vector indexes so vector indexing will be done on the volumes inside the Databricks, where we can basically store content or on the delta tables, and then the LLMs will serve it as an endpoint, as a chat endpoint. So you can do all those jazzy stuff too there, including the machine learning, training the model, and creating your own models, things like that, to share it with the rest of the world. So those are the core components. Those were the core components that we have used. Now, what is a medallion architecture? Maybe this term is new for many of us here in the meeting, but it simply means that you have a bronze standard, you have a silver standard, and then you have a gold standard, right? Those are the medals, right? If you see Olympic, it is derived from there, the medallion architecture, which means that you have. So on the left hand side here, data sources, you have different varieties of data sources: structured, unstructured, semi-structured, IoT devices, APIs that you call, right? Databases, various kinds of databases. You have a Sybase, you have SAP systems, you have Azure SQL, you have Oracle, you have different kinds of databases. Third-party systems. We have in the company I work for, they have weather sensors across the fields in Northern America, and they want to report, and they have a Kafka event bus that they push their weather related data to. Now it's helpful for the farmers to know the data because they can make informed decisions based on the data, and they want to get hands on to the most recent weather information as soon as possible, like max precipitation, wind speed, things like that, right? Future, like it's going to rain, things like that. So those are very important to protect the seed and then take the right measures. So it is very important for them to get the data hands-on so that they can take those informed decisions. That was just one use case that I was sharing. Now, how do you go from that unstructured, semi-structured data to go through all these layers, like bronze, silver, and gold? In our case, now every company has their own terminology. In the company that I work for, we use raw for bronze and refined for silver and presentation for gold. Doesn't really matter. Under the hood, it's the same thing. So bronze is where you store data as it is without minimal transformation, right? So you have, let's say if you're calling an API, right? I would store an API as it is. I would have a UID column there, unique ID identifier, and then store the whole response as a JSON. It has the ability to store different kinds of formats. So JSON is one of them, and I store that there as a string literal. The whole 200 response that I get back from the API call. In the refined layer, so basically you have the raw layer that way, that you don't have to touch it. You just have to store it as it is. And then when you go from raw to refined, you have some quality checks in place. Like the example I was sharing, that if I have an API which has the entire response in a column, I would explode that into different columns in the silver layer, right? Instead of storing it as a JSON, I would store it as a row and column format, where all my elements will become the properties and the values will become the rows for that properties. So elements becomes columns and the rows becomes values of the columns. That's one example. The other example is if you have a lot of nulls and if you have a lot of bad data, then you can clean it up. You have formatting issues in the data, the date timestamp, things like that. You can clean those up. You can get rid of unnecessary columns in the silver layer, and store it accordingly. You can standardize your column names, right? The raw could have different column names, but the silver layer could have a different naming convention that represent the same column. You can apply business rules on the silver layer. And of course, the format is the delta format, right? All the files are stored as Parquet files behind the hood. When you go to gold layer, this is mostly for your reporting purposes, where you even refine further. You create aggregations, right? You create models for your business users to consume through Power BI, through Tableau, or through other dashboards. You create models for your machine learning scientists that, this is the cleanest form of data that we have. This is aggregated. This is a mashup of everything that we know of that has the most business value. You can also involve your business partners here to help you when it comes to the gold layer. That's what we've been doing. We are asking them to participate in creating these gold layer formats with us, because they know the data and they know what they want. They necessarily do not need everything from the refined layer or from the silver layer. They are looking for good quality analytical related data that they can report off. They want to cut the noise and they want to cut the clutter. So the other benefit to the gold is that you can have a lot of performance optimization. So we were doing some performance tuning, and we were comparing performance from a traditional warehouse to a data lake, from a traditional data lake kind of a warehouse, or a data warehouse to a lake house. And we saw huge differences. So we had a table with 100 million records that was taking forever to populate and copy over. Even though we were doing a differential merge, it was to take at least for a full refresh. It was taking, so we refresh every hour and then we refresh every week, a full refresh. So that used to take at least 6 to 8 hours in production environment. And we had the best like we had the best compute on the Azure side for the database. When we tried to test that on the Databricks side, it just took us 2.5 to 3 minutes to copy over the data, the 100 million records. So that gives us that kind of a performance. And then when we connected that to our Power BI report, we were doing apples to apples comparison of a Power BI report connected to the Lakehouse, to the data warehouse, compared to connected to the Databricks Lakehouse, and we saw massive performance improvements there. So queries that were taking half a minute were running in sub-seconds. So then there is also a lot of good features that they have. Instead of partitioning, there is something known as liquid clustering, where you can do on your materialized views. Now these can all be relational databases, or these can also be big databases, like big query databases. Most of the times I have worked on relational databases, so I can only speak to that. So when I say liquid clustering, it means it's more like a partitioning concept, so partitioning is where you take your low cardinality columns and create partitions, like date, time, year, or an ID specifically that does not change very often. And then liquid clustering is where you can combine 2 or 3 different columns and create clusters. And Databricks would determine how best to partition it and how best to cluster it, so that it can give you optimal performance. So we are using a lot of those techniques in our presentation layer to speed up the queries and speed up the end user experience. So improve the end user experience. I'm sorry. So those are some of the things that you can do in each layer. And then there is time travel. There is schema evolution, time travel. You can go back and see how the data has changed, right? Those kind of good features available out of the box. Now, how do you get from your unstructured, or how you get from your data sources into the Lakehouse? There are several ways. There is a Azure Data Factory that we are using currently, because it supports a large number of connectors. Now, there is a connector there's a SAP table connector to connect to SAP. There is a Azure SQL connector, of course, to connect to Azure SQL databases. There is a ODBC connector to connect to on-prem databases through a self-hosted integration runtime. There are other kinds of connectors too that you can connect through, like a blob container, right? You can also connect to a Lakehouse, the delta table format, Parquet files, things like that. That it's endless, and they keep adding connectors, every 6 months or so. So that gives a lot of flexibility. Plus, it's a no-code solution or a low-code solution, which empowers a lot of our team members to write the pipelines very fast, in a very efficient way. It's Git controlled. You can basically connect it to your DevOps pipeline, and you can do CI/CD. So it's even better, because then you can collaborate. Multiple people can work on the same pipeline. That's why I personally like ADF, and I've worked with it a lot, and it's pretty robust. The other thing that we are also doing is, for some of the workloads, is Databricks Autoloader for streaming scenarios, where you have streaming data, files are coming in a streaming fashion. We have to read the streaming hub, like an event hub or a Kafka events. Autoloader helps a lot, cut down a lot of extra code because there are a lot of built-in functionalities like merge and apply changes and things like that with the autoloader. We are also exploring a third functionality, which is recent, which is a Lakeflow connector, where you can use Databricks that eliminates the need of an ADF completely. Because if you use a Lakeflow connector, then you are basically querying the data right from the source, querying directly from the source and getting your data pulled in. It needs a lot of Python code, and there are some out-of-the-box features that we are still exploring. But having said that, Data Factory is equally powerful and probably cheaper than Databricks, for that matter. Any questions here on this diagram? If not, I'll keep proceeding. The Delta Lake architecture. Now, what is a Delta Lake and Spark SQL? Now, these are the fundamentals of the Databricks Lakehouse, right? So as I said, the Delta Lake is the storage format, open source storage format. Essentially, as I said, everything has, is a Parquet file, the transaction logs, and it's stored on the ADLS Gen 2 storage. So there is very good compatibility with the ADLS Gen 2 and the Delta Lake tables and the files associated. There is version control, and you can time travel, you can do schema evolution, things like that. You can see how your data has changed over a period of time. Asset transaction, schema enforcement, schema evolution, things like that. All good stuff. And yeah, time travel to query your historical versions. Spark SQL integration, very much like SQL, but a lot more powerful than SQL, right? Pretty much the same syntax. So if you are a SQL pro, you don't have to relearn, and that's why they have a Spark SQL engine behind the scenes. You can write basically notebooks in not just the plain old SQL, Spark SQL, but also use Python to write your notebooks. I think it also supports Java, even though I've not tried it. But for the most part, I have used Python and Spark SQL to write my notebooks for data engineering primarily, and also for writing apps. Spark SQL advantage, again, it's same ANSI SQL compliance, cost-based optimization, code generation, right? Runtime code compile. Yeah, there is the good feature is that there's a compilation engine, and then that helps you a lot to compile your code and catch your issues earlier. Columnar processing and runtime optimizations, and it's also used for mixed workloads. Like if you have a batch workload versus a streaming workload, you can still use Spark SQL there. Moving on to the next slide. Again, my context for the research was the company that I'm consulting currently, Global Seed, and this company has it's a very well-known company across the globe. Has a good presence, seed protection, seed quality and crop protection products, some digital products as well for the farmers. Complex data from different sources, as I said, IoT data, weather, soil conditions, and regulatory compliance requirements for each region. Well, East US 2 versus China or other places, North America, Canada. Previous architecture was traditional warehouse with several data lakes, right? Hadoop style data lakes. Data inconsistencies. We saw a lot of data inconsistencies. People not able to figure out where the data resides, and spending a lot of time. Governance overhead, long time. So if they didn't knew where why the data was not accurate or why did it fail, they have no clue at the time. So we implemented. So the technology stack on the right hand side is what I spoke for, like Databricks Premium with auto scaling, and Delta Lake 2.0, Data Factory, ADLS Gen 2, Unity Catalog is what we have now, and then Power BI Pro. Now Power BI comes with different licenses. Now they have Fabric licenses now. The Pro versus Premium, and there's always a debate on which one is best. I think for the most part, Pro should be good enough. Premium has a lot more features that I like out of the box, but it's expensive. Implementation approach, iterative methodology. We went with a iteration based methodology that we didn't try to do everything together. We were taking single use cases, converting single applications or data that that data that resided, like database A, for example, right, which has crop protection data. We took that, for example, and then we converted that to we created the catalog and schema and delta tables, moved over all the data and showed the value to the business, and then moving over to the next. So the first one is difficult because you have to write the pipelines and the data engineering you have to do the data engineering in such a way that you can reapply those things for the other databases that you're going to convert to a lakehouse, right? Or you're going to bring in. So that's always been a challenge, which we were able to do through metadata-driven frameworks in Databricks. So everything comes from the configuration, and then you can write your pipelines, just one and done kind of pipelines, where you don't have to write individual pipelines for each and every data type or each and every data source, I would say. Progressive data migration. We are still in the process of migrating a lot of data because it's a never-ending process. Medallion architecture pipelines. We have, again, the data going from raw to refined. So we have a common notebook that we have created to move data along. So the data, I can explain overall, like a high level what we do. We get the data from different sources. We drop it into our blob container through ADF, right? The pipelines run in the ADF, and we have a metadata driven framework where we read from the metadata, and that's how we wrote the ADF pipelines to read from that config table, get the table name, and get the source table information and things like that, and then dropped it as Parquet files. Then the notebook the Databricks workflow will be kicked off to run to pick up those Parquet files, and that common notebook will basically go from raw to refined to presentation, or gold to silver from bronze to silver to gold. So that's the medallion architecture pipelines I was talking about. We also enforce row column level security as different settings in notebooks, depending on what app or what database we're talking about. Performance tuning and optimization. Again, this is a ongoing process. For the most part, liquid clustering has been very, very promising to us from what we saw on the presentation side. Plus, writing materialized views on the presentation layer is very, very good idea. It makes the performance even faster. Because materialized views are different than regular views. A regular view is just a snapshot of your table, but the materialized view actually contains the data for your underlying tables from the refined layer that you can refresh at a frequency. Like, there is a very simple syntax for that. Create materialized view, name, and then for refresh cycle, how frequently you want it refreshed: 30 minutes, 1 hour, like 2 hours, 1 day, month, whatever. So that has been very promising to us so far. So our presentation layers is mostly aggregation tables, and we're still using the start schema for our refined layer, so dims and facts. But then eventually, when we want to present it to the end users, it's mostly materialized views. Now the gain, this is a comparison of the actual data that we captured. We took certain examples of databases and reports that were taking a lot of time before implementation or before moving over to Databricks. Like query performance, there was a use case that we saw where it was taking 45 minutes. We brought it down to 22 minutes, right? Standard query performance went down drastic, 60% faster. Data freshness, we can bring in data faster, so there's more 92% improvement there. Storage cost went down too, because storage is cheaper, and you have to optimize it. There are a lot of optimization techniques on the Databricks to optimize storage using delta tables. And it's compressed since it's columnar, right? Compute cost went down 30%, because we were very, very vigilant in using the job compute or serverless whenever needed. We were also having we also had issues where people were starting the compute but never stopping it. So we had idle computes running and creating issues. We have a budget policy in place now, which means if some random machine learning scientist creates their own compute and just start spinning like crazy, it will basically hit the budget, and then we'll just not go beyond that, and it'll stop his compute cluster. So that's what we enforced to reduce the cost for computes and people not creating computes across, and then starting small with the less number of cores, and then eventually scaling up if needed. Most of the times we have seen optimal performance with even the minimal compute or minimal cores, right? 2 cores or 4 cores versus 16 cores. Data quality issues, again, we were able to remediate a lot of undetected and unstructured and bad quality data. So there was a 97.5% improvement there. Again, as I said, the key benefits that we realized were 50% performance gains. As I said, this was dramatic. The performance gains were the real value additions, that we were talking about earlier, to the business folks, and why we wanted Databricks. Data quality, again, as I said, we detected a lot of data quality issues, and we're still figuring it out, because there's new data coming in all the time. Cost optimization, we were able to bring down the cost. Governance, 40% more robust governance now. Security, administration, overhead reduction, because again, there is a unified catalog which can be shared across teams. So you can have multiple lake houses in your company and you can share the catalogs, so that way you don't have to recreate them. Days, like time to market for new analytics, like if we have a request today, I can get it up and running in, like we had a request today, last week for an SAP workload. They wanted some data. We were able to get it up and running in like 2 weeks or maybe less. 2 weeks. 1 week was for the performance and things like that. But the ETL, I mean, the data engineering and creating the model and materialized view and all that is pretty quick. Compliance, we were able to get 100% compliant on our regulatory requirements, be it security or governance and things like that, tagging the assets, things like that. So overall, very the business was very happy when they look at the benefits realized here. Again, this is a slide I want to bring your attention to. Like it's not just Databricks out there. There are other products out there too. They're major competitors. Recently, as recent as like 2 days back, Gartner has listed Databricks as a leader in the Lakehouse area and the data science area. So there you can look at the Gartner latest publication. It's categorized as a leader in this space. So there are other competitors. Snowflake, I know a lot of folks who work on Snowflake and they are happy with it. The biggest strength being data warehousing and SQL workloads and things like that. Strong in traditional BI. Google BigQuery, serverless data warehouse, 5x more customers than Databricks and Snowflake. And then the market is the Google Cloud ecosystem. So even this is very powerful. I've not worked with it personally, but I've heard good things about it. Amazon Redshift is where my previous company was, and they liked it. I did not. I'm not a fan of that. Azure Synapse, or mostly like more recently, I would call it the One Lake from Microsoft. This looks promising, and I like it for a lot of reasons. The underlying architecture is still Synapse and the MPP clusters that they have, and this is also equally good. But again, as I said, I've not explored a lot. So Databricks advantages like ML, AI, analytics, all in one platform, and open standards, data science, focus on data science, and now on AI as well. Lakehouse architecture, a true hybrid approach, right? Multi-cloud, like support for multi-cloud, as I was saying earlier. You can have Azure, AWS, and Google Cloud support. So competitive challenges, now again, Google has the biggest market share so far, because of the penetration and presence that they have across the globe. Simplicity, Snowflake has more SQL, easier for more pure SQL users. So if you have a company where we have traditional SQL users, then Snowflake is, people like Snowflake for that. More SQL support that way. Learning curve here, what we have seen is you need to have some knowledge, learn a little bit more on SQL Spark and Python and things like that. So there's a lot of coding needed to get things up and running, even for the basic pipelines. But that will change eventually, because they're bringing in new features all the time, especially the Lakehouse Connect pipelines and the DLT pipelines. Cost complexity, more complex pricing model, that's for sure. They are more expensive, I would say, or reasonably expensive, I would say, compared to the other products out there. Again, this is just a high level competitive analysis, right? For each product. I don't know if you are interested to go through this, but essentially, Databricks ranks high in almost all the areas. If I see here, ease of use is says medium, because it requires Spark. So that's a little bit of learning curve and challenge there. But overall, I see the Photon accelerator is great for performance. The Photon speeds it up. It's like crazy fast. It has a lot of horsepower there with the photon enabled on your cluster. So moving on to the challenges that we had, right? Always there will be some challenges in a project, that any project that you execute. Could be requirements gathering, or it can be choosing technology, or it can be team size, or not good team members or whatever. Uh, but we also had some similar challenges. The learning curve was very high initially, to set up the pipelines and the infrastructure and the DevOps pipelines for that and things like that. Data modeling, again, creating a model or creating a consistent structure and guidelines, or how we do raw from go, and how we go from raw to refined to presentation. That was a challenge initially. Operational monitoring, yeah, this was a big area, because we wanted to monitor the cost for the and then budget policies and things like that, because it can be expensive if you leave it unmonitored. So monitoring was a big thing here, which we initially did not pay attention to when we were setting it up. So we had huge bills in our company, and we were asked for. So that was one of the reasons that we had budget policy, and choosing optimal computes and terminating the cluster when it's not in use, and good practices being followed. Um, Legacy integration, yes, custom connectors for older systems, and we had to play around on ADF side, for especially for SAP, that we had to play around, open the ports and things like that for SAP, and things like that. So those were challenges, definite challenges that we had encountered initially. There were some organizational challenges as well, moving away from traditional SQL mindset. Right, people did not like the idea of going to write a lot of Python for their pipelines. They were preferring like a one lake or a fabric one lake architecture, where you don't have to write a lot of stuff. It's all software as a service, and you just drag and drop things like that. Um, Skill gap, we wanted some robust data engineering skills in our team, and there was a skill gap, obviously, because not a lot of us were, or not a lot of us knew the in-depth of or insights of Databricks at the time when we started. So there was a skills gap, which we had to eventually bridge by self-learning and trainings, and Databricks does a good job of assigning um, like resources for your company when you partner with them, that they can give you in-person trainings or virtual trainings and things like that. So that was a good thing to learn faster. We had to use some of those resources that they had. There's also a Databricks Academy page, learning catalog page, where you can see videos and also do in-person trainings, all for free if you're tied up with Databricks. Governance, discipline, enforcing data modeling standards. Yes, we defined our own standards for refined layer and presentation layer. So column names have to be in this format, have to be casing and things like that, right? Pascal case or camel case or whatever. So those were nitty gritties that we had to bundle up um, in terms of governance. Key success factors: iterative approach always helps. You don't have to do everything at once. You can do it iteratively. That speeds up your development, and you can show results, get things done faster, and also reduce your risk. Training investment, yep, you had to do a comprehensive team of scaling, as I was just talking about, with the help of Databricks. Strong governance, Unity Catalog implementation from day one. We had to use that because we didn't want to go to the Hive Metastore, as it was deprecated. So there was no point in going there. Performance focus, early optimization of critical workloads. Yes, so the workloads I was talking about, where we had that table with 100 million records, that was an example that we optimized it early, liquid clustering, and identifying unique columns, things like that. Again, best practices from my experience, that if you are doing it in your company, if you are getting started with Databricks, start small, pilot, fail faster, and reduce your risks, right? Failing faster is better than, succeeding faster, because it gives you a lot of findings from your own failures, and then you can implement them. And if you failed small, you always have a chance to go back and recover, and then recoup from that failures. Invest in monitoring. There's a comprehensive observability that we got through dashboards. There are inbuilt dashboards which are great, that you write a query and then it can create a chart for you. And there is dashboards that you can generate, and you can also reuse a lot of dashboards. We got a lot of dashboards from the Databricks itself. They had a lot of cost related dashboards, performance dashboards. Those were JSON files that we had to import. So that was very helpful, because they had a generic set of dashboards that we could leverage without writing new. But you can always write your own dashboards too. So standardized early. We created our model standards very early, and naming conventions, and those were helpful. Uh, Otherwise, you see a lot of variance when it comes to standards for data modeling. Security first. Again, the security has to be first in every project that you work on, and this was not an exception either. So we were focused on securing the data and from raw to refined to presentation. So those were some of the challenges in implementation, that we had. Now, future directions, as per that I've documented in my paper, is that we want to do a lot of AI ML integration, deep integration of ML workflows, ML flow within Lakehouse. So we should be able to pick up those presentation layer models and write machine learning algorithms on top of it to derive sentiment analysis, for example, or classification regression models, arrive at decisions, things like that. So multi-cloud patterns, right? Advanced implementation patterns for cross-cloud data sharing and governance. So we have a research on AWS, and we are primarily using Azure. We want to partner with them, and we want to share our catalogs with them, even though they are on AWS and we are on Azure. So those kind of challenges we want to address in the future. AI-driven data quality remediation and anomaly detection techniques. We want to use more of that in the future. Those are more research opportunities. Extreme scaling of performance of data set, right? Optimization for data set exceeding 100 petabytes. We have not touched this so far. So semantic layers, right? The semantic layers, like where you have like your Power BI semantic layer, right? We want to make it more metadata, like the business friendly semantic layer, and optimize that semantic layer. When you publish from Databricks to a Power BI semantic model, let's say. Real-time analytics, streaming analytics, and streaming decision-making capabilities. So real-time analytics would mean that how fast is my, having a dashboard where I can present to the end users that this is the time we take to load data from SAP or from other source systems, and real time, mostly real time with the streaming fashion, if it's coming from Event Hub and things like that. So those are some of the future research opportunities we have. Now, emerging, of course, we all know that the generative AI is a very, very, very hot right now. Databricks is coming up with a lot of these apps, out of the box apps for RAG-based chatbots, for machine learning, where they're creating apps. It's very easy to create apps with Python as a backend, and configuring it with your LLMs and vector indexes, and it in fact has its own vector indexing engine in the UI itself. So edge computing now, distributed lakehouse patterns, quantum computing, serverless computing, these are all industry standards. I'm not, of course, worked on quantum computing, but it's just that where the industry is shifting currently, right? Business drivers like data mesh, privacy regulations, sustainability, cost optimization, FinOps for data platforms. This is where the industry is going, right? So just wanted to highlight that here. Decentralized data ownership models and things like that. And the last thing is the key takeaways here that I wanted to share were the foundation was the Lakehouse data lake, and the benefits that we derived of it. We saw proven performance gains with every data set that we were including in our Lakehouse, and then creating reports out of those. We saw massive improvement before after. We were able to measure it because we had the before up and running, right? We had existing traditional data warehouses up and running and the reports connected to them. And when we connected the same reports to our new model with some optimizations, of course, they were a lot more faster, cost effective. Compute cost was, we brought down the compute cost significantly by following some best practices, and the enterprise ready architecture with Unity catalog. So strategic recommendations, as I have covered, and I'll cover it again. Start with the pilot, begin with non-critical data domains to build expertise, invest in skills, team training on Spark, Delta Lake, and data modeling, and then governance. Always implement Unity catalog from day one for compliance. We have had teams who did not go this route and have to migrate now. So there's a lot of cost associated to that. And I think I am done with the presentation. The floor is open for questions and discussions. Sam.
Excellent job, Mehul.
Yeah.
Does anyone have any questions or comments?
Excellent presentation. Thank you.
Oh,
Hi, my name is George Lott, and we started our Databricks journey about 6 months ago. And so we're kind of, still learning as we go. One thing that you mentioned is, the amazing support that you get from Databricks as a
yeah,
corporation, which is, top notch. A
yeah.
couple questions for you. Are you utilizing serverless at all?
Yes, we are.
Okay. And how's that working out for you?
Um, it's fine. It spins up faster than the all-purpose job compute. That is the benefit. There are some changes that we are making to make it more efficient and performant. But so, for example, we were trying to use it for our workflows. All our workflows were on job compute, and we are trying to play around, and we are going to compare cost between job compute versus serverless that way. But the serverless is a lot more faster. I don't know if it's going to be very cost effective though.
Okay, thank you. Second question is, how about Delta Live?
Yes, DLT pipelines. Yes,
Yes.
Delta Live. I like Delta Live tables personally. Recently, I wrote a pipeline on a DLT pipeline with Delta Live tables. The good thing I like about them is you can declare the tables. You can define your table and columns declaratively
Yep.
using a syntax like a link syntax in .NET. Right? You define your columns, your types, and things like that, and properties on the table. Which is very handy. Plus, you can also do a cloud format, which means you can do a streaming. You can load them in a streaming fashion. You don't have to worry about whether you will duplicate the data, because if it's in a cloud-based format, there's like a delta.cloud format where it makes
Hmm.
it streaming. And if you have hundreds of files drop in one day, it will exactly know which file it has loaded and which it has to load, right? So
Yep.
the DLT pipelines is a way to go in the future. Now, even though having said that, in our company, we started with Delta Live tables, or sorry, Delta tables, and not DLT tables. So because we wanted more control on the naming conventions and standards, and we didn't want developers to define the column names and things like that. So we had a data modeler, dedicated to define the DDL scripts, right? Data definition language scripts, table creations,
Hmm.
um, setting properties on the tables. So we had that requirement. So that's why we are not doing Delta Live pipelines currently. We are doing workflows right now.
Okay.
But I'm personally fascinated by DLT. I just implemented one where we are getting we wanted to monitor workspaces of Power BI workspaces, right? So we had no clue how many people in our company have how many workspaces are there in the company, how many reports people have written on these workspaces, and how many reports are being actively used. Some of these workspaces are on premium capacity license, and if they're not being used, we are still paying for them, right? So it
Hmm.
makes no sense. There is no visibility. If you have 50,000 workspaces in your company, there'll be no visibility unless you monitor it. So the only way to monitor it over a long course of time. So Microsoft does it for 90 days for you. Like you can create, but it is a very limited time period. There are companies who have report usages for specific seasons. Like for example, in our case, seed quality or crop protection. There are users who would use the reports only for 3 months in a year, but they still need those reports out there. So if you want to go beyond 90 days, you have to write something custom. There are a lot of custom solutions out there, so we didn't like them. So we wrote our own very simple um, monitoring mechanism where we were querying these Microsoft APIs. I was querying those Microsoft APIs, reports, workspaces, and user activity. Those are the three names of
Hmm.
those APIs. And getting all the data, store them in the Databricks, raw, refined, and then presentation is where you basically just do a simple mashup of how the workspace one, how many reports, and of course report A, how many users
Hmm.
or user activity, like a Google Analytics basically. Very simple. So for that, I use Delta Live tables. Coming to your point, so I love that I was able to create the whole pipeline in one day and execute it. That was so fast, right?
Yeah.
Once you have the bits, and you can call the APIs directly from Databricks, or you can have your ADF get the data for you in Parquet, and then you can read the
Hmm.
Parquet and load it to your raw, refined, and presentation layers. Yeah.
Yeah,
So I
we
liked it. I like
decided to
DLT. Yeah.
go. Yeah, we decided to go all in with DLT. Just, it seemed like, that's where a lot of the innovation was going. And so we decided to do that. And there have been a few challenges with it because it is kind of, a new emerging product for them. But I think at the end of the day, it'll be beneficial.
Yeah,
And then one last question, the facts and dimensions, do they live in your silver layer or your gold layer?
silver.
Silver. Well, that's what I thought. Okay.
Yep. I think I
And
did
I don't
mention
know.
that for the most part, we wanted our silver layer to have a star schema, and then the presentation
Mhm,
layer was just an aggregation, like materialized views mostly.
mhm, okay. Because I don't know. I don't know if it was just because of the way DLT was processing the data, but it's like we're landing, and we have a metadata-driven approach through Data Factory as well, and we're
Hmm.
landing, the Parquet files in the lake, but then we have to create a pipeline to take them from the lake into managed storage in DLT format, and that's our bronze, and then to silver to gold, and we seem to be one extra step and kind of one layer behind
Hmm.
what seems logical to me. So, and like I said, I don't know if it's a DLT thing or what, but
So
seems a
if you
little
have a
backwards from what you
yeah,
described.
I mean, if you have a DLT pipeline, it should just pick up the parquet that you
Yeah.
are landing, like in your raw landing zone, right? Um, Through the ADF. I would say it should just pick it up and process it, right? In our case, um, because we have delta tables, so we have this one common notebook where we use that to process that data in our raw, refine, and presentation. I mean, raw and
Mhm.
refine, and then presentation comes later with another notebook, but mostly raw and refine. So the beauty of our approach is that it's one and done approach where you write the common notebook, it will take care of the column formats because it's all metadata driven.
Right.
um, it knows how to map the columns from raw to refine, and it just brings the data from Parquet and loads it that way. But the beauty of your approach is that you don't even, it's very easy to use a delta live table to just read that location where you're dropping your Parquet files, and it'll take care of the rest for you, including the merges and all that stuff, incremental
Yep.
load.
Yep.
And
Excellent. Thank you.
yeah, 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 we are going more towards that though.
There's also a question posted by Kevin, and he's asking, does it mean your work require paid subscriptions to three services, DLT, Databricks, and Azure?
No. So the Azure Databricks will have its own costs because it's its own service, or its own subscription. Um, and then the DLT is part of the Databricks. So the DLT can be associated to um, all-purpose job cluster or a SQL warehouse compute, and I think even serverless. No, serverless also. So, uh, I mean, I don't know if that was the question here. You Because your Databricks is a part of your Azure infrastructure, so you will need to have Azure for sure. And Databricks would have its own licensing cost or own subscription cost accordingly. If that answers their query.
Kevin is still with us. Does that answer your question, Kevin? All right. So no replies from Kevin yet. However, feel
Oh,
free
okay.
to jump in with any questions or comments, either in chat or verbally. I just have one comment to make. I thought the charts that you had laid out were absolutely brilliant, quite honestly. It summed everything up,
Oh,
and
yeah.
it gave a very concise picture of everything that we were looking at and able to contrast and compare. So, job
Perfect.
well done with that.
Thank you, Sam, and thanks for the
Yeah,
opportunity. Appreciate it.
absolutely. Thank you for joining us tonight. Before we adjourn for the evening, have a couple slides that I'd like to go through. But first, I'd like to draw your attention over to the chat window. There's three links that I posted, and we'll go through those at this time. Let me go ahead and share my screen. All right, so if you look over in the chat window, you'll see that there's a link for the YouTube channel. If you would please subscribe to get the upload notifications once this video is edited and uploaded. In addition, there's a link to my blog, and that's where tech events are posted. And again, please subscribe to that to get the updates. And last but certainly not least is the feedback eval form. Please take a moment to fill that out so we can provide Mehul with some constructive criticism. With regards to events, on June 19th is the Greater Lansing User Group.net. That's going to be happening online. It's every third Thursday of the month. And I invite you to check out their meetup website. That is also posted on my blog. And then the week after, June 26th, is the Cleveland C# User Group, hosted by yours truly. We don't have a speaker lined up yet, but it will come together before that time. With regards to conferences, on August 1st, which is a Friday, is Cincy Deliver, that's happening in Cincinnati. That is an all-day event of agile and various topics relating to development and as well as data. And that is an all-day session happening on August 1st. So the website for that is cincydeliver. Oops. Sorry, jumping all over the place. My bad. The website for that is posted on my blog as well. On August 13th through the 15th, 2 weeks later, is KCDC, also known as the Kansas City Developer Conference. And as you might have guessed, that's happening in Kansas City. And that is multiple days, including a pre-compiler day or a pre-conference day of various topics. So check out their schedule, kcdc.info. If you're in the job market, I invite you to check out devitjobs.com. So that is a website that allows you to filter on whether you want to work remotely or in person, the geographical region, the type of technology, and it provides you a map of where these various jobs are located. And lastly, if you need to get in touch with me for any reason, my email, snasser@nistechnologies.com. You can also find all my socials on Linktree/Sam Nasser. And my favorite platform, LinkedIn. Your network, what others are working on and what they're posting. So if we're not connected there, please, let's do so. And so with that, thanks again to Mehul, and thanks for all who attended, and hope to see you all at next month's meeting. Good night, everyone. Yes?
There's one more question from Kevin.
Sure, go ahead.
Yeah, so the question is, for data transformations in Delta live tables, does SQL or Python do this task better? I think it depends on your situation. I mean, you choose either. There's no restriction as such for the Delta live tables. You can either use SQL for the entire notebook for your Delta live table, or you can use Python all the way through. So that's the answer here. Apart from that, there is one more thing, Sam. So there's a Databricks, AI and Databricks conference, which is probably they're claiming it to be the world's largest conference next week from 9th of June to 13th of June. I'll be there. If you guys, any of you are going to be there, we can connect. It's in San Francisco, and it's starting on 9th June.
Very good. Did you have the link for that?
Yeah, I can throw in a link here. Conference. Yeah, there's this. Here we go. Data plus AI Summit. Here we go. That's the link.
All right, very good. Thanks for sharing that.
Okay, thank you.
Any other questions or comments? All right. Thank you all for joining, and enjoy the rest of your evening.